Welcome again in this series of titration. Today we want to look at this question. As you can see, you are provided with solution M, hydrochloric acid, solution N containing 8.8 grams per liter of sodium hydroxide, and then we have solid P, which is 0.5 grams of an impure carbonate. So the most important thing is to understand or to put in mind solution M is HCl, solution N is sodium hydroxide, a base and an acid, and then we have a carbonate here. So it is important to understand this information, because the reagents are going to react. You should know which one is reacting with which. What are you required to do? Determine the concentration of solution N in moles per liter and the percentage purity of the carbonate solid P. Procedure: fill the purate with sodium hydroxide, solution N, pipette 25 centimeters cube of hydrochloric acid, solution M, into a conical flask. Add 2 to 3 drops of methyl orange indicator and titrate. The color of the indicator changes from pink to orange. Record the results in the table below. So we have been given the final purate reading. We have 26.4, 26.2 and 26.3. So let us take the initial to be 0.0, 0.0, 0.0. So we are going to have here 26.3, 26.2, and then 26.4. It is important for you to know what is in the purate. It is sodium hydroxide. Therefore, the volume we are going to get here is sodium hydroxide solution N. Solution N. So the solution N is in the purate. What we are going to pipette is HCl. So hydrochloric acid is going to react with HCl, and the reaction will reach the end point, and that is neutralization will occur. And so let us get the average now. Calculate the average volume of solution N used. Average is 26.4 plus 26.2 plus 26.3 divided by 3. This one is going to give you 26. Let us take 3. So this plus this plus this is 7, 9. Yeah. So because of 2 decimal places, we can put a 0 there. That is our average volume. Next question. Calculate the concentration of N in moles per liter. Moles per liter. Concentration in moles per liter is molarity. Molarity is given by mass in grams per liter divided by RFM. So, you remember this one? Always put it in mind. Always remember this molarity. RFM, mass in grams per liter. So if we want molarity is equal mass in grams per liter divided by RFM. So mass, remember we are talking about N. N, here is our N. Our N is here. N, how was it prepared? Contains 8.8 grams per liter. So that is what we call 8.8 grams per liter, because it is 8.8 in 1 liter. So you come here, we have 8.8 divided by RFM. RFM of sodium hydroxide is 40. Yeah, 40. Sodium hydroxide is AOH. So 23 plus 16 plus 1, the answer is 40. This one gives you 0.22 capital M. Okay, next. Remember the question here, calculate. Calculate concentration of solution M in moles per liter. In moles per liter. Ni kwa nini nilikwambia lazima uwe umeelewa? So M is reacting with sodium hydroxide. So we must have the equation first. So lazima uandike equation ndio ujue the reaction. Although tunajua sodium hydroxide na HCl, the ratio is 1:1 because it forms sodium hydroxide, sodium chloride plus water. The ratio is 1:1. It means that the number of moles of sodium hydroxide is equal to the number of HCl. Oh, yes, sawa. Already tuko na sodium hydroxide tulitumia ndio hii solution N 26.30. This one was 25. Tushapata moles, hatujapata moles ya hii. Now we can get, but we have the molarity of this. Sawa? So let us get the number of moles of sodium hydroxide that was used. We know the molarity of sodium hydroxide is this. This is the number of moles in 1 liter. So 0.22 capital M means, implies that 0.22 is the number of moles in 1,000 centimeters cube. What about this one? 26.30. What will be the number of moles? So E times E times E will give you 0.00578 moles. Sawa? Sasa unajiuliza ni kwa nini tuna calculate sodium hydroxide ambayo ni solution N? Ni kwa sababu lazima tujue moles ya hii ndio tujue moles ya hii automatically using the ratio. So now I know the number of moles of HCl is the same as this. Kwa nini? The ratio is 1:1. Now moles of HCl solution M equal to this is this, because the ratio is 1:1. 0.00578 sawa. And I have explained why, because the ratio is 1:1. Tukishajua moles ya sodium hydroxide tutajua hii automatically because the ratio is 1:1. But the question was asking us to calculate the concentration in what? In moles per liter. So this is moles in 25. So this is 25 centimeters cube of solution M ambayo ni HCl iko na 0.00578 moles. 1 liter, because we want concentration in moles per liter. 1,000 centimeters cube will have how many moles? 1,000 times 0.00578 divided by 25. This one is going to give you 0.2314 capital M. So the molarity of HCl is 0.2314 moles. Yes. Thank you. Let us go to the next question. Next question, not a question actually, next procedure 2. Procedure 2 says that using a measuring cylinder, measure out 100 centimeters cube of solution M into a beaker. Add all the solid B into the beaker containing solution M. You swirl the mixture and allow the reaction to proceed for 4 minutes. Remember, P is a carbonate, M is an acid, hydrochloric acid. So that is a reaction which will take place, carbonate plus an acid. You should know that. So label the solution contained here as Q. So after the reaction, we label that solution Q. Fill the puree with sodium hydroxide solution N. Pipette 25 of Q solution Q into a conical flask. Add 2 to 3 drops of methyl orange indicator and titrate. Record your result in the table. So we have recorded this result here. 16, our initial is 0, 0.0, 0.0, 0.0. So let us get the subtraction. 16.0, 16.1, 15.9. Let me assist you to understand what is happening here in this procedure. That's why it is. If you don't understand what is being told here, it is not possible for you to proceed downwards. Now the HCl is in excess. It's going to react with the P, and some acid is going to remain, which is going to react with N, which is a base, sodium hydroxide. So the head 100 centimeters cube of HCl solution M will react with P. Some HCl will remain after reacting with P. So that is the solution we are going to label Q. After that, we are going now to react Q. What is Q? Q is HCl that was in excess. That will be in excess because some HCl will react with the P and some will remain. Also, the concentration is going to reduce. The concentration of Q and the M is, this one is higher concentration, lower concentration, Q. Q is HCl, which is the row with less number of moles. So average volume of N. N, remember, is sodium hydroxide, no problem. So it is 16.0 plus 16.1 plus 15.93, which will give you 16.0 centimeters cube. Moles of hydrochloric acid in solution Q. Now here it is sodium hydroxide which is reacting with HCl, but this HCl is not M but Q. This is Q and this is N. So this one is 16 centimeters cube and this one is 25 centimeters cube, which will give you sodium hydroxychloride plus water. That's what you get. For me to get the number of moles of HCl solution Q, I must get the number of moles of sodium hydroxide, and then I get the relationship, because this one has been diluted. I don't know anything about it, but I know so much about this. I know the concentration, I know the volume that was used. Therefore, we can get the number of moles of sodium hydroxide. Yes, so we know the concentration of this. It was here, sodium hydroxide. The concentration here is here. So in 1 liter contains 0.22 m of sodium hydroxide. So you can say here that 0.22 is the number of moles in 1000 centimeters cube solution what? N. What about 16 centimeters cube? So this times C times this, this one will give you 0.00352 moles. Now this is the number of moles of sodium hydroxide that reacted with HClQ. But now we know the ratio is 1 to 1, meaning that the number of moles of this sodium hydroxide is equal to the number of moles of HCl solution Q. So now 25 centimeters cube of Q contains 0.00352 moles. Mole ratio equal to 1:1. Hiyo umemaliza. Sawa. Let us go to part number Roman 3. Calculate, remember you are using calculate the number of moles of hydrochloric acid in 100 centimeters cube of Q. Now we know the number of moles in 25. What about 100? 25 centimeters cube solution Q equal to 0 moles. 100 centimeters cube solution Q will contain what? So this is times this divided by this. That one is going to give you, remember it is 100. This one is going to give us 0.02314 moles. That's very good. Let's look at the next page. Calculate the number of moles. Calculate the number of moles of hydrochloric acid in 100 centimeters cube of the original hydrochloric acid solution M. Original. But we know the concentration of the original. We know the concentration. We know the molarity. So molarity of M is here. M, concentration of M moles per liter, it equals 0.2314. So this is the number of moles in 1000. What about 100? So 0.2314. So we say 0.14. What was that? 2314. 0.2314 moles is in 1000 centimeters cube of solution M. 100 centimeters cube solution M will be how many? This times this divided by this, which will give you it will give you what? I think we have done a mistake there. Here, this times this times this. Here we have done some mistake here, some error here. Roman 3. 100 this times this divided by this. The answer is not this one. The answer should be 0.01408 moles. Yeah, sorry for that. Now this times this divided by this will give you 0.02314 moles. Moles, calculate the moles of hydrochloric acid that were used in the reaction with solid P. Now, remember, we had 100 centimeters cube of the original. So now we have the number of moles of the original and the number of moles of 100 Q. Now we can get the number of moles that reacted with P by subtracting the number of moles of 100 centimeters cube M and 100 centimeters cube Q. If we subtract that, we get the number of moles of HCl that reacted with P. So that's what we are going to do. That is 0.02314 314 minus 0.01408. This one will give you 0.009064. This is the number of moles of HCl that reacted with P. Moles of the carbonate that reacted with this one. That one we will know. There's something which is missing here, the ratio that reacted given that, so we can add something here. Given that the mole ratio between the carbonate and the acid is 1:2. So carbonate and the acid, the ratio is 1:2. So, but now we have the number of moles of the acid that reacted with P, which is the carbonate. So the acid in 2, what will be this? That is going to give you half of it, you see. So moles of P equal to 0.009064 divided by 2, which is going to give you 0.004532 moles. Given that the relative formula mass of the carbonate is 106, calculated the mass of the carbonate that reacted. Mass. But we know mass from this triangle. Moles, RFM, mass. How do you get mass? Mass is equal to moles times RFM. Now we have moles of the carbonate P, and we have the RFM. Now we can get mass. So mass equal to moles times RFM, 0.004 times 106. This one gives you 0.326304 grams. Percentage purity of the carbonate P. Remember the carbonate P, the total was 0.5 grams. But the mass of P only, because it was in P or it was contaminated. So the mass of P only is 0.3, and the impurity is around 0.1 and something there. Therefore, we want to calculate the percentage purity of the carbonate. Percentage purity. So we put the pure that is 0.326304 divided by the original mass times 100. That one gives you the purity, percentage purity, which is 65.26%. Thank you for your time.